All right, pre-calc students, welcome to day 5 of graphing the sine function. So what we're going to do today is put together the three things that we've learned so far: amplitude, period, and vertical shift. So let's just review what we talked about in the 444 notes with just doing the vertical shift. Now, one thing I want to point out to you is what we saw yesterday. It would have been written like sine x and then plus 5 on the outside after it, but it can be written like this where the vertical shift is written before it. What you need to remember is that anytime you have a number that's being added or subtracted to your trig function, that is a vertical shift that will move the graph up or down. So let's start off with our parent function again, like always. So again, if you've been keeping up with all the notes, you've seen this many times. So nothing new here with our parent function. And even when we get into cosine, we're going to start off with the same coordinates on our x and y axis. It's just cosine has different answers, so the graph will look slightly different. It will have the same general look to it, but it will look slightly different. So here we go. The sine function. So we have f of x is equal to sine x. So we're starting out 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Again, I'm going to run through this quickly because we've seen this, I don't know, maybe a dozen times already. Okay, so the 5 right here is going to take this whole graph and shift it up 5 units. So my low point here at negative 1 will get moved up to 4. My point at 0 will be moved up to 5, and 1 will be moved up to 6. So we're just taking all these y coordinates and adding 5 to them. So what my new graph will look like, again, my x coordinates are not changing, so I'm just going to recopy those down here. Pi over 2, pi, 3 pi over 2, and I can fit 2 pi in there. You can see that. I'll scroll up a little bit. But like I said, my y coordinates, my low point is going to be at 4. So I'm just going to put a line here and call it 4. You could put 1, 2, 3 in there if you want to. 0 will be moved up to 5, and 1 plus 5 is 6. All right, so everything is just getting shifted up 5 units. So f of x is equal to 5 plus sine x. All right, so let's track all these points again. Here we go. First point, 0, 0. Well, 0 plus 5 is 5. So I have my point at 0, 5. Pi over 2 was at 1. So 1 plus 5 is 6. So I got a point up here at pi over 2, 6. Next, pi was at 0. So 0 plus 5, again, gives me 5. So I'm at the point pi 5. 3 pi over 2 is at negative 1. Negative 1 plus 5 is 4. And 2 pi was at 0 plus 5 gets me back up to 5. And again, the math here is not difficult. I mean, everybody in this class can do everything that I just did right there. 0 plus 5, 1 plus 5, negative 1 plus 5. That is not difficult at all. I know there's a lot of steps in here, but each step is pretty simple. You just have to be able to follow everything. Okay, so that's why I've been spreading this out over like 2 weeks. Like, we're taking a lot of time on this. We will go through cosine a lot faster because it's the same process. It's just, a different graph, but I wanted to take a lot of time going through sine. So there's reviewing the vertical shift. So again, I put this same, my computer's freezing. There we go. I put this same I don't know what you want to call it, not a graphic, but this list of things. This is what we've covered so far. So the amplitude, we're going to put all this stuff together now. Okay, so the first graph I'm going to do amplitude and vertical shift, and in the second example I'm going to do amplitude, period, and vertical shift. Okay, I'm not going to label the frequency for now. We're going to talk about that later on, but we're going to label amplitude period and vertical shift in these graphs. Okay, so I'm going to do that in the beginning of each step. Okay, so here we go. And again, the order matters that you do these in. Okay, it's kind of like your order of operations where you got to do the multiplying before you do the dividing. Okay, so keep that in mind. We're always going to start off with our parent function, so that's nothing new. But after I do that, this -2 is going to be my first graph. I'm going to do that one in green. And then my +1 is going to be my second graph, and I'll do that one in red. Okay, so I'm going to start off with the, like I said, I'm going to start off with the parent function, like always. So give me a second to throw this up here, and then we'll go through each of these steps again. So pi over 2, pi. I really should have just like made a copy of this originally to save some time on these notes, but oh well. All right, so first up, we got f of theta is equal to sine theta. Parent function is what we're always starting with, all right? So, and you got to start with all this, with this in all your graphs, every problem. Again, it'll help you to memorize the function without ever really needing to memorize it, just by going, like doing the same problem over and over and over and over and over again. You will be able to know what that function looks like without, like I said, without having to memorize it later. All right, so first up in this green graph, we have a -2. So that is your amplitude, okay? So I'm just going to label that to begin with, all right? So my amplitude, I'm going to abbreviate AMP. The amplitude is the absolute value of A, which is -2. So the amplitude is 2. Remember, this is half the height of the graph. So if we look at this graph right here, there's a 1 in front of sine, which means half of the height is 1. And we could see that because this goes from 1 to -1. So that has an overall height of 2, right? This is 2 units. Going from -1 to 1 is 2 units. So half of that, the amplitude is 1. All right, so we are going to, so graphically that's what it is. But algebraically, all we do is take this number, -2, and we just multiply that by our y values. All right, so let's go through this. I'm going to write my function down first, so I can make sure I have enough room. So -2 sine theta. Throw some parentheses around that if we want to. Not really necessary. All right, so if I take, let me scroll up here a little bit. If I take all of my y values and I multiply them by -2, there are two things happening here, okay? Two things happening. First of all, the graph is going to be stretched out because it's going to go up to 2 and down to -2. But the other thing that's going to happen is because there's a negative in here, it's actually going to flip it as well. But first of all, 1 times -2 is going to get down to -2. And then -1 times -2 is going to get me up to 2. All right, so again, we're going to have two things happening in this graph. It's going to be a flip, and it's going to be a stretch. All right, so we're going to show that here in the first graph. So let's see what happens. All right, let me change my color. So remember, the math is not difficult, okay? Don't overcomplicate this. This is not difficult at all. All we're doing is taking all these y coordinates in this blue graph, the y coordinates, and multiplying by -2, okay? So the first y coordinate is 0. Well, what's 0 times -2? Well, that's still 0. Next up, pi over 2 is at 1. Okay, so all we're doing is 1 times -2. That's not difficult at all, okay? 1 times -2 is -2. Next up, pi. Well, pi is at 0. Well, 0 times -2, again, not difficult. That's 0. 3 pi over 2 is at -1. -1 times -2, that puts you up at 2. And remember, 2 pi has to be where 0 is. But again, if we look at this, 2 pi is at 0. 0 times -2 is -2. All right, so like I said, two things happened. It stretched it out to 2 and -2, and it also flipped it because of that negative sign. All right, next up, vertical shift. The vertical shift here is 1. Okay, and you can put a little +1 there if you want, just to indicate that it is moving up 1 unit. So what are we doing? Well, we're going to take all of these y coordinates at 2, 0, and -2, and we're going to move them up 1 unit. So we're taking those numbers and adding 1. Again, not a difficult process. Excuse me. Not a difficult process to do. 2 + 1 is 3. That's easy. 0 + 1 is 1. Again, pretty easy. -2 + 1 is -1, which might be the most challenging one to do, but still not that difficult. All right, so when I draw my graph here, I'm going to put my x-axis down a little bit because everything got shifted up. So I'm just going to put that down a little bit. So I'm going to put all my marks here. So 2 + 1 is 3. Next up, 0 + 1 is 1. Okay, and then the last one that we're going to do, -2 + 1 is -1. That's a little not proportionate, but you get the idea. Okay, so let's put our x coordinates on here. So we got pi over 2, pi, 3 pi over 2, and last 2 pi. All right, so again, we're going to track these points. So where was it in the green graph? Where is it going to be in the red graph? All right, so let's start off with our first point. And again, we're looking at the y coordinates, okay? So the y coordinate here is 0. I'm adding 1. So 0 + 1, it's going to move me up to 1. Next up, pi over 2 was at -2. All right, -2 + 1 puts me at -1. Pi was at 0. 0 + 1 is 0. 3 pi over 2 is at 2. 2 + 1 puts me up here at 3. And 2 pi was at 0. 0 + 1 puts me at 1. All right, so all it did was take all of those y coordinates and shift them up 1 unit. Okay, so it takes all the y coordinates and shifts them up +1, so it's going up 1 unit. Okay, so there's your final graph for the first example. All right, so we're putting 2 things together here. We did amplitude and vertical shift. This next example is going to put everything together that we've done so far. All right, so, and again, I'm going to do my multiplying and dividing before I do my adding and subtracting. All right, so I'm going to start off, first of all, I'm going to start off with my parent function, and then the 3 is going to be first. And I'm just basically working left to right here. I mean, it's not really anything new. This is all stuff that we've seen before. So my purple graph is going to be my second graph where I do my 1/2. And then my red graph is going to be my -4. That's going to be my third graph. All right, so we got 4 graphs here, starting with our parent function. All right, so we're going to go through each of these steps just one at a time. All right, so first up, f of x. I didn't want to do that. I want to put that in blue. Sorry, I'm trying to color code everything to make it a little simpler, hopefully, for you. So let me do my coordinate plane here. And we're going to go 1, -1, pi over 2, pi, 3 pi over 2, and 2 pi. All right, here we go. F of x, parent function, sine x, 0, pi over 2, pi, 3 pi over 2, 2 pi. All right, so first up, the green graph. Again, the green graph is our amplitude. So the amplitude is the absolute value of 3, which is just 3. And again, all that's doing graphically is it's going to stretch out the graph. All right. Algebraically, we just take all of our y coordinates and we multiply those by 3. All right. So let me draw this y coordinate here. X coordinates are staying the same in this graph. The next graph, they will change because the next graph is our period, which will affect the x coordinates. It may still look the same, but the x coordinates will be different. So not in this graph. This graph, the y coordinates changed. So we got pi over 2. We got pi. Oops. Whoa. We got 3 pi over 2. And we got 2 pi. All right, what color? We're doing this one in green. Okay, so take all your y coordinates and multiply by 3. First up is 0. Well, 0 times 3 is 0. Next up, pi over 2 is at 1. 1 times 3 is 3. Pi was at 0. 0 times 3 is 0. Pi over 3 pi over 2 is at -1. -1 times 3 is -3. And 2 pi was at 0. 0 times 3 is 0. So connect your dots, and this is going to be stretched out a little bit more. That graph was not good. Let me try again. This is going to be stretched out, 3 times. Oh, my word. Stop. This thing's freaking out. Let me try again. 3rd time's a charm. Oh, maybe not. All right, so connect our dots. We go up. I should have just left it go the first time. This is ridiculous. There we go. So there's your graph. We go up, down, up. Again, graphically, this is just multiplied by 3, so it's just stretched out in the y direction. Okay, next up, we're going to do this purple graph. All right, so the purple graph is taking all of our x coordinates and dividing by 1/2, which is the same thing as multiplying by 2. And again, I think it's easier to multiply by the reciprocal. So I'm going to do all my work over here, and then I'll transfer all those points down. So next, for the period, we're going to start off with 2 pi, and we're going to divide by b. So b is the number in front of x, which, again, we can write this as 1/2. Like if you wanted to write this as 1/2 x, you can. So we're going to divide this by the absolute value of 1/2. Okay, which is the same thing as 2 pi over 1 multiplied by the reciprocal, which is 2 over 1. So that means my period is 4 pi. Which really just means my last point is 4 pi. So what do the other points look like? Well, let's just run through them here real quick, and then we'll put them all on the graph. So we're going to start with 0. Well, not start with 0. We started with 2 pi. Next up is 0, and we're going to multiply. This step right here is the same. We're going to do this to every one of those points. Multiply by the reciprocal of our denominator. All right, the denominator is 1/2. Multiply by the reciprocal. So 0 times 2 over 1 is 0. Next, pi over 2. Multiply that by 2 over 1. The 2's cancel, and I'm just left with pi. Next up, pi. You can put pi over 1 if you want to. Multiply by 2 over 1 gives me 2 pi. And the last point was 3 pi over 2. And we're going to multiply that by 2 over 1, which again, the 2's cancel and leaves you with 3 pi. Okay, these 2's would cancel here. All right, so there's our points. 0, pi, 2 pi, 3 pi, 4 pi. Which again, there should be a pattern, right? So we know that there has to be a pattern in all this, so that was kind of an indicator there. All right, so my next function, again, let me just fill this in here. So we're doing f of x, We already did the 3. Now we're doing the x over 2. So my y coordinates are not changing here. All right, so let me extend my page here to give me some space. So I'm still doing -3 to 3. All right, so 3, -3. But what is changing are the x coordinates. So we got 0 was the first one over here, 0. Then we had pi. Then we had 2 pi. And we had 3 pi. And the last one was 4 pi. Okay. And with all of these functions, really the x coordinates they're usually the more challenging ones. The y coordinates are pretty simple. They're very straightforward. But the x coordinates with the period and then the phase shift, the last thing that we're going to do in the 4, 4, 6 notes, like those are the last, like those, anything dealing with the x coordinates are always more challenging, but it's simple math. It's just a lot of it. So anyway, let's put our graph down here. So we started out, let me look at the previous one. I'll try and get them both on the screen here. We started out at 0, 0. Well, 0 got moved to 0. It did move. Okay, so that's still 0, 0. Then we had pi over 2 at 3. Well, pi over 2, we could see right here, pi over 2 got moved to pi. So that's over here at pi 3. And it's still going to have the same general look to it. It's just the x coordinates are changed. Okay, next up, pi was moved to 2 pi. So 2 pi 0. Okay, because we were at pi 0. Now we're at 2 pi 0. Next up, 3 pi over 2 was moved over to 3 pi. So 3 pi over 2, -3, gets moved over to 3 pi, -3. And then the last point, 4 pi, is at 0. So here's our graph representing the period change of, with the 1/2 in there. All right, last function. Here we go. Last function, we are going to do the -4. All right, so what does -4 do? Well, -4, I'm going to erase this stuff over here just because I want to make sure I have enough room to do this. So hopefully you have that down. If not, rewind it and write it down. So next up, -4. All right, so f of x, let me write down the function here and then we'll talk about it. So we have 3 sine x over 2. We already did those 2 steps. Now we have the -4. So we're back in the y coordinates, dealing with the y values. So the -4, what this is going to do is going to take all of these y coordinates and subtract 4. So let's look at our top number. If we have 3 minus 4, 3 minus 4 is going to give us a -1. Next up, 0. 0 minus 4 is going to give us -4. And then the last one, -3 minus 4 is going to give us a -7. All right, so I don't have anything above the x-axis here. All right, everything is down here below the x-axis. But I'm going to rewrite my points here. So pi, 2 pi, 3 pi, and 4 pi. All right, so let's track these points again. Starting off at 0, 0, -4 gives me 0, -4. Then I had pi 3. 3 minus 4 is -1. 2 pi was at 0. 0 minus 4 is -4. And then 3 pi was at -3. Minus 4 is at -7. 4 pi was at 0. 0 minus 4 is -4. So there is your final graph after all 3 parts. And hopefully your graph is a little smoother than that. This is kind of a little messed up here at the end, but I'm not going to try to fix it because it'll get all messed up like it did earlier. So Anyway, that is all the parts that we have done so far: amplitude, period, and vertical shift. Okay. So, again, like I've been saying, if there are any of these things that you have questions on, send me an email or a private comment and I can go over things with you. But otherwise, try your homework problems, and you got some examples there to work through, and just let me know if you have any questions.